just one night, I'll try my best to make it worth your while. And so, on the count of 3, 1, 2, we go to prom with me. On the count of 3, just take my hand, we'll dance like there's no tomorrow. All dressed up like we're ready to go, so say yes and leave it all to chance. Our hearts will sing to the beat of the drums, we'll scream the chorus to every song. Come with me, each moment last.
Our final topic chosen is the length of prom dresses for seniors, and we are using Chapter 8 to test a claim about a proportion using the traditional method. The reason we chose this experiment is because Kelsey and I believe that the majority of seniors wear long dresses for their last prom, and we just wanted to see if that was true or not. So our question we're asking is the proportion of seniors with long dresses greater than 0.75? We will be surveying senior girls only from May 3rd to May 8th, and it will be surveyed in classrooms where we have a signature from the teacher who will let us survey. The way we are asking the senior girls is we'll be going into the classroom and asking only for the girls to answer, the senior girls, and we'll ask them to raise their hand if they are wearing a short dress, and we'll count and have a clipboard on who is wearing a short dress, and then we'll do the same for the long dress girls. After we surveyed all 60 senior girls, we decided to pick every other girl and then decide if we should reject or support the claim.
So now we are going to test a claim about the proportion. Our significance level that we're going to use is alpha equals 0.05. And that is because it's a standard and the results don't need to be exact, but they should be accurate. And this will be a right tail test. And that's because if you look over here, P is greater than is our claim. So this is called a one prop z test for P, and P stands for population proportion. So since we know it's a right tail test, on the graph using the traditional method, you shade to the right. And next, we look to find our test statistic, which we use using this formula. So P is 0.75, and that was given to us in the question. Q is 1 minus P, so it's 0.25. N is the sample size, so we had 30 people after we were all done randomizing, and P hat is the number of successes, which is 25 over 30. Successes means that it was a long dress. That's 0.833 repeating. So to find the critical value, which is our next step, we need to have 1 minus alpha inside the A2 chart and match outside to the z-score. So 1 minus alpha is 1 minus 0.05, which is 0.95. And if you look in the chart, that means the critical value is 1.645. So if we plot our data on the graph, if this is 0, then our test statistic is here. And so once we plug all of those numbers in, this is how we arrive as the test statistic equals 1.054. Since it's 1.054. However, our critical value is this line right here. So our critical value is 1.645. So as you can see, our test statistic is not in a shaded region. Since it's not in a shaded region, we fail to reject the null. So given that H1 is our claim and that we failed to reject the null, then our conclusion is that we do not support the claim that the proportion of senior girls with long prom dresses is greater than 0.75. What this means is that less than 75% of senior girls wear long prom dresses. We were satisfied with the results of our experiment because it answered the questions we wished to answer. The results were surprising since it seems like every year a vast majority of seniors wear a long dress. Dress shops and department stores would be interested in our results to see how many of each type of dress to order. A follow-up experiment should test junior girls to see if the trend continues.